Innovation Enterprise webinar in association with the RedPoint Global and Hortonworks. We're still waiting for a few people to log in, but I think we'll get started now. I'm delighted to introduce you to Jamie Keefe, who's Product Manager at RedPoint Global, Justin Sears, who's Senior Manager of Product Marketing at Hortonworks, and Chris Toms, who's Solution Director at RedPoint Global. Today they'll be presenting the Eliminating the Challenges of Big Data Management Inside Hadoop webinar. There'll be time for a Q&A session at the end, so please post any questions that you have in the Q&A box located at the right-hand side of your screen at any time. Over to our first speaker, Justin.
Thank you, Deanna. Let me start with a little bit about our company, Hortonworks. Hortonworks was founded by the original architects of Apache Hadoop with the goal of developing the platform into a key component of the modern data architecture. They wanted to take the platform originally developed at Yahoo and extend it into industries other than big web properties, industries such as telco, financial services, retail, manufacturing, healthcare, and many more. To do this, Hortonworks has always followed a consistent three-part strategy. First, develop everything in the open through the Apache Software Foundation. This is the fastest path to innovation. Secondly, partner with technology partners so that Hadoop complements existing data center investments. And also partner with our customers to develop a platform that meets their standards for enterprise rigor. Let's start from the beginning. Traditional data storage systems were designed in a one-to-one relationship with the apps that consume their data. By today's standards, data was scarce and curated with a schema on write type of architecture. But the world has changed since then. Now, most data created doesn't fit neatly into predefined columns and rows. We're talking about clickstream data, geolocation, web data, Internet of Things, documents, emails, server logs. This is the data that's driving 85% of the growth in global data. And as I mentioned, it's very difficult to store this data at scale in the aggregate. And this is really the reason that Hadoop was originally developed at Yahoo. They needed to address one particular use case, which was indexing the world's websites. It was great at some things, but it had its limitations. So traditional Hadoop, the advantages were it could manage a new data paradigm, so it could take any type of data and use a schema on read rather than a schema on write paradigm. That means Hadoop is great for storing video, clickstream, sensor data, all those types of data that I mentioned before. It handles that data at scale, and it's cost-effective and also open source. But the first version of Hadoop did have some limitations. It was a batch-only architecture, and so this led to single-purpose clusters with specific data sets. It was also difficult to integrate with existing investments in the enterprise, and it was not enterprise-grade. It lacked services for governance, operations, and security. In October of 2013, the Apache Hadoop community released Hadoop 2 with Yarn at the center of its architecture. Now Hadoop with Yarn takes its place alongside other data center technologies in a modern data architecture. Yarn enables applications to have access to all of your enterprise data through an efficient centralized platform that negotiates the access to that data. And it's also supported with a centralized approach to governance, security, and operations. What this means is that Hadoop is versatile to handle any applications and any data set, no matter the size or type. And I'm very excited to be speaking here with RedPoint today. Yarn provides a predictable big data operating system that partners like RedPoint can develop around. So RedPoint offers solutions that take advantage of Yarn so that analysts and DBAs can keep doing what they do so well, but now with the big data in Hadoop. A little bit about paths to adoption. We see the hundreds of customers that we support on HDP They're all different industries, but they tend to follow a pretty standard path to adoption. One big initial driver for adopting enterprise Hadoop is cost optimization. And we see our customers do one of three things. They archive data off of their EDW. So in any given EDW, most data is not used very frequently, and that data is still stored at a relatively high cost of storage. So we have customers that move that data off their EDW into Hadoop. Also, because of the schema on write architecture of traditional systems, many companies have to do costly ETL processes to make the data fit in the predefined structures. You can do this in Hadoop, and that's a great way to get some of the efficiency out of the platform. And then also those other types of data that I mentioned, the ones that don't fit neatly into the EDW column and row structure, you can bring that data out of your EDW and enrich it with those new types of data and then bring it right back into your EDW. We see many customers doing that. So about a third of our customers start with a cost optimization use case in the beginning. And 2/3 start with, on the other end, trying to gain new revenue by building advanced analytic applications. So there are many examples on this slide, but you can see across the different industries, we see pretty predictable patterns in the type of applications that our customers build. They build applications for a single view of their customer or their operations. They build applications to do predictive analytics, do machine learning on sensor data, and predict things that might happen in the near future and then take proactive action on that. And we also see data discovery use cases, these new types of data, exploring that data, combining data sets that used to be isolated and finding new insights that way. However our customers start, we see a pretty consistent movement towards a data lake architecture. And this means they might start with one cost optimization use case and then add new analytic apps. At a certain point, there are more users in the organization and many applications that become business critical. HDP with Yarn at its center makes all this data accessible for any app, any type of user simultaneously. And it really unlocks what we call systems of insight. So our customers can build advanced algorithms and applications that take advantage of a much richer set of data, both in the type of data, but also because of the economies of storage, people can store data in HDP a lot longer for the same cost that they might be storing it in other platforms. A great example of this is our customer TrueCar. TrueCar, over a 13-month period, started with a relatively modest cluster, and then they grew that to an extremely large Hadoop cluster, and they recently, actually the middle of last year, they went public. The key driver here for TrueCar is they can store data on car purchases from across the United States. It's about 4% of car purchases now go through TrueCar in the US, and they can only do that with the very efficient cost of storage in HTTP. So you can see here they were looking at a cost of $19 per gigabyte, and they initially started at 23 cents per gigabyte with HTTP. I recently heard one of our contacts from TrueCar mention that they've got that down to 12 cents now because they're at such large scale. So I want to set it up for Jamie. Let me just talk a little bit about the platform, and I think that'll tie in really well to Jamie's remarks. I mentioned Yarn, and the key thing about Yarn is it delivers a centralized architecture. So many different applications can plug in to analyze data in Hadoop through Yarn. And we see applications that are for batch. We also see new applications for interactive SQL query and also real-time analysis. This Yarn as a data operator system provides a consistent layer, predictable layer that third parties can develop around. And that's exactly what RedPoint has done. This is our distribution. And you can see there are many components to the Hadoop cluster. Many of these components are for different types of data access or for developer access. But then I also mentioned governance, security, and operations. Any enterprise needs these enterprise services, and we also provide those as part of our distribution, developed in the open source community in the same way that we develop everything else. The key takeaway is that HDP is useful for any data, any application, anywhere. All those types of unstructured data I mentioned are stored economically in Hadoop, as well as your structured column and row type data that you may already be working with. So you can bring that out of your enterprise data warehouse or your existing operational structures, enrich it in Hadoop, and move it right back in. And also anywhere. We deploy HDP in the cloud or on-premise, on device, on Linux or Windows. In any application, we work very closely with our partners to make sure that they can build applications at whatever layer of the stack to work well with HDP, so that our customers don't need to eliminate anything that's already working well for them in order to adopt HDP. And we do this through support subscriptions. We work very closely with our customers from the very beginning of their life cycle with Hadoop. As I mentioned, we've been through this process now with hundreds of enterprises. And we work with them during the architecture and development phase, implementation, and production, and then expansion. I mentioned TrueCar. We started with them small, and that cluster, many of other customers have expanded to many times their initial footprint with HDP. And we've been doing this for a while, and we've been recognized for being leaders in our support. In the beginning of 2014, we were recognized in the Forrester Wave, received a 5 out of 5 for customer service, and that was a superior ranking than other Hadoop distributions. We're very proud of that, and I'll point out that ranking we received when we were supporting version 1.3, so that was even before Yarn and a lot of the innovation that I've discussed. So now I'd like to turn it over to Jamie to talk about RedPoint and how RedPoint plugs in and works so well with Hortonworks Data Platform.
Great. Thank you, Justin, and thank you, everybody, for joining us today. Having lived through these challenges in the recent 5 years, I understand the pain associated with what Justin was describing, particularly from an analytics perspective, working with a 200-node cluster and 2 petabytes of raw log data. We see RedPoint as delivering an innovative way to make big data accessible to business users so that they can achieve value, buffer Hadoop's complexity, and leverage the human and data resources they already have and are most familiar with their in-house data. This can provide the fastest way to serve up access to business applications and get Hadoop into production. So RedPoint was founded in 2006 by Dale Renner, who had started Accenture's $1.5 billion CRM practice. And RedPoint has global reach and is recognized as a leader in marketing platforms for highly targeted cross-channel communications, as well as the underlying data management. Our customers are comprised of a lot of different industries, including financial services, retail, and the big credit bureaus. But most importantly, RedPoint is the only native Yarn data management solution available today. So Andrew Brust is a respected industry analyst, and he's made the argument that business applications are what will unleash the power and promise of Hadoop to a large range of business audiences. Data management might be the unglorious part of data processing, but it does have enormous impact, not just on analytics, but also on the ability of companies to make decisions through their other applications. To illustrate, we'll describe how to overcome the challenges Justin has raised, and then we're going to demonstrate some of the key attributes in our application. So a lot of the infrastructure for data quality and master data management have been around for a while, but the limited amount and the limited variety of data involved stands in stark contrast to what's happening today. These older architectures become overwhelmed when trying to handle these new data sources that can run into the petabytes in size. And we propose and work with our clients to use Hadoop for building a point of ingestion for all of your data. Not only a point of ingestion, but also a point for all data quality processing. Some of these data quality processes are quite difficult, and matching an address or people's records across these data types is computationally intensive and difficult to code. But this can be eliminated by RedPoint using non-programmers. And it makes sense to do this where you have inexpensive storage, computational scalability, as well as one other key piece, and that's the granularity of the original raw data, and you can go back to this as new data requirements emerge. So analytics, BI, and machine learning are three more important reasons to preserve your raw data. Raw data is where the behavior lie, not in the aggregates that might reside in an enterprise data warehouse. And from a statistical point of view, you want to see this minute by minute, month by month, months over months, and how things change. And this is the data that fuels predictive modeling and machine learning. So wouldn't it be great if the applications you already have deployed could access Hadoop processed data, and to access all the data together with all the heavy lifting and computing optimized by Hadoop and its scalable computational platform? Yes, there are challenges, but solutions are available. These technologies are new, and the required skills and competencies can be rare. Core data management functionality that you'll need are ETL and ELT for grabbing and receiving data. Then there are web services for listening for data, with service ports for grabbing data in any format. And then there's transformation and placement of the data. Next is data quality for cleansing, correction, completion, standardization, and formatting. And when you're dealing with people data, addresses become critical. Then comes matching, fuzzy matching, and data integration. These are not once and done kinds of actions. The ability to track over time, to produce master data management is critical, and this is where you track relationships between people, people and addresses, people in households, people in cars, and people in their devices. Some of these functions can be done in a single drag and drop, and all can be done from a single app that enables existing and new apps. Yarn is the key for RedPoint data management being able to do this all in Hadoop. Yarn stands for yet another resource negotiator, and it provides a data operating system essentially sitting atop of HDFS. In Hadoop 1, we were limited to MapReduce and Pig for getting into HDFS and doing processing. But in Hadoop 2, everything including MapReduce now go through Yarn at either an API or an engine level. And I'll just point out these levels on the slide as the API level and the engine level. And a very high percentage of the tools that work through Yarn do it at the API level. However, if you can speak native Yarn, you can write an application master, and Yarn will instantiate all the core engines of your application master to actually run in Hadoop, just as MapReduce does. Without an application master, it's not native Yarn, and coding will be involved. This and the previous slide are important for a lot of reasons. The RedPoint application master runs faster than MapReduce. Running as an application in Hadoop unleashes the real power of Hadoop. In our case, we're able to split our jobs up and run across a cluster wherever the data that we need resides. And this is where the power of parallel processing resides, and it translates into speed. This is also the reason why there's no coding associated with our application. The UI replaces any need to generate MapReduce code to run in Hadoop. Our application, and as well as all of its capabilities that we've offered in the last decade, are running natively in Hadoop. And one of our tools is called the Hadoop container, and it allows you to drag and drop any tool function from the palette into the container, effectively telling our application that these operations and processes are to happen in Hadoop. We behave as a law-abiding app in Hadoop, meaning that Yarn is allocating cluster resources to us. And because we're working in concert with Yarn, we clean up after ourselves, leaving the environment in the same pristine condition in which we found it. So this is part of what we mean when we talk about a zero footprint for RedPoint in Hadoop. This illustration depicts the other half of our zero footprint story. Our application sits on an execution server outside of the Hadoop cluster. We do not install on the cluster itself, and only the operational functions you see inside the little parallel section box are running on the Hadoop. So the job and the logic inside this box is the application master that we send up to Yarn. And between Yarn and our application master, a number of things happen real fast. Yarn figures out where the data is that we and sends our application master only to those nodes. Yarn then reshuffles the data so we get even processing. And when the job's done, Yarn evaporates our application master. The other aspects that's important about being located outside of the cluster is that we can also access other enterprise databases. Working in a client-server mode, we can bring everything into Hadoop, process it there, or across all of the databases in a hybrid architecture environment. We can set up a job that pulls data from Teradata, from Oracle, run it through Hadoop, and aggregate the results out to an SQL server, or leave it on Hadoop as high prepared data. So Project Gutenberg is a word count problem derived from a volume of ebooks, and it comes with some of the Hadoop distribution. Its primary purpose is to help you check and make sure that you stood up your cluster correctly and ensure that parallel processing is working correctly. We factored it by 30K, which is a lot of words, and our benchmark involves counting them up to see how many occurrences of each word happen. It's a great problem for distributed processing. And first we coded in MapReduce, and we had to clean up some of the small file problem. It required 150 lines of code, 6 hours of development time, and it ran in 6 minutes. Next we did it in Pig, and it needed one user-defined function. It required 50 lines of code and 3 hours to develop. But look what happens when you intermediate. Things start slowing down, and our runtime was 15 minutes. Then using RedPoint data management, we required 0 lines of code. We could develop it in 15 minutes, and it ran in 3 minutes, which is pretty cool that we were actually able to run faster than a customized job written in Java and MapReduce. But this is possible because RedPoint already had a distributed processing architecture underlying our application. This is what allows us to take advantage of what Yarn has to offer. So this is a new processing environment, and the giants of data management in the relational space have big installed bases there that are difficult not to focus on 100% of the time. And we believe that this allows us to focus on big data and be more innovative and nimble and actually run circles around some of these guys when it comes to doing big data management. And we do it in a way that takes data management to where the data is. We leverage the parallel processing and scale of Hadoop, and we enable business resources in your organization who understand your data and how to integrate it with third-party data that cannot scale on your enterprise data warehouse. Hadoop is a different platform, and we believe it's a better platform. At RedPoint, we've always thought about data management problems in a different way, and Yarn enables us to perform really well. What you're looking at here are some graphs from a recent Gartner study called Gartner Critical Capabilities for Data Quality Tools, and it demonstrates that RedPoint is the most relevant data management application across a range of contemporary use cases for data quality. And we ranked here #1 for operational and transactional data quality, as well as data integration. And ranking in the top 3 for data migration, big data, and information governance initiatives. So if you want to get your business team up and running in a production state as fast as possible in the most cost-effective way, give RedPoint a try. And the need for Hadoop and big data is not the question. The reality is that while Hadoop technology, cost, and processing advantages are all proven, the maturity of the industry is still relatively young. When an enterprise thinks about mainstreaming Hadoop, they're thinking about whether they can take their workforce and get them all to work with the new technology without having to retrain everybody or even replace the workforce. RedPoint helps you achieve master data management across big and traditional data environments, and with the persistent entity resolution, linkage, and keying, and while buffering the complexity and enabling you to leverage your existing DBAs. The way to make Hadoop easy is to give people an interface that they can work with to be able to do workloads without having to be super skilled code jockeys. So if you recall Justin's slides and on the main modern data architecture and how Hadoop helps you reduce costs and optimize the value of your enterprise data warehouse. This brief demonstration shows that it's not necessary to have a team of Java programmers writing MapReduce jobs to enrich the value of your ERP or your EDW. In our scenario, a business analyst is scrubbing existing customer registration profiles against purchase transactions. The use case is to identify not only account purchases but also guest purchases made by our registered customers and update the 26 million record customer profile. My colleague Chris Tomes, our solutions director at RedPoint, is running the demo, and Chris starts the job by pulling in transactions from our ERP using the icon for relational database input. On the way into this job, Chris standardizes this data against the U.S. Postal Database because he plans to match against the customer profile data using name and address. This will increase match confidence later, and Chris does this using the icon for address quality. Next, Chris creates a sales file of the metadata which will append itself to each record by pulling in an icon for source definition. Defining the metadata now will be beneficial in future matching needs and provides an automated way to identify original data sources. Chris then tells our app to push these results into Hadoop for processing against the customer profile records that reside there. Chris starts by opening an icon for Hadoop parallel section, and he partitions the results of the ERP transactions by zip code. This will distribute the zip code data across the cluster and nodes upon arrival in Hadoop, and Chris uses the icon for input connected to the Hadoop section for this. Partitioning the data in this way will leverage the parallel processing characteristics in Hadoop. Once inside the parallel section, Chris begins by pulling in the customer profile data that persists in Hadoop. And Chris segments this data by zip code as he did earlier for the sales transaction data. Chris then drags in the metadata function, the same icon for data source definition, applying it this time to the customer profile data, and he's naming this accounts. I'm getting a little bit ahead of him. Next, Chris drags in into the parallel section the merge icon to integrate the two data sets before doing matching. As Chris drags in the function, he uses the palette search to quickly display this tool and then drags in the consumer match icon and connecting it into the workflow. It's worth noting here that there are also specific tools for doing business versus consumer matching, as well as tools that can create match rules for custom entities. As Chris prepares to geographically match the fields in these data streams, he shifts over to the property sidebar to set the matching and the standardized address fields. And he picks the names and address as well as the gender. And what the gender is going to allow him to do is to differentiate on similar names like Alexander versus Alexandra. And now as Chris begins setting to match the probabilistic tolerances, I'm going to pass the mic over to him so he can describe exactly what he's doing.
Thank you, Jamie. So what you see here in our match tool is the ability to, once you've actually mapped the fields, to say what fields you are going to match on. In this case, name and address. I can then go into our name tab and configure how exactly I want to do the match. So in this case, we brought in the gender field. And at this point, we want to use that gender field to be able to distinguish between male and female. So as Jamie mentioned, Alexander and Alexandra. We also can do things like match the first and the middle, where we would compare the first name of one record to the middle name of another record in the event that the first name and middle name were flipped or switched between records. You will also see that we have the ability to set what kind of threshold you want on performing that comparison. So this ranges anywhere from exact, being byte for byte the same, all the way down to very loose. In this case, we allow for a lot of errors between the two values. In this example, we're going to go middle of the road and stick with medium. Now, while we provide you with some guidelines or some groupings of what those scorings or how tight or how loose the match is, we can actually be able to leverage our own score if we find that through testing one of the predefined groupings is not quite what you need, so you can manually put in the score that you want. Again, we'll go with the middle of the road match. We can also do the same thing for the address. You'll notice you have some options around how do you treat comparing two addresses in between records. We also can set the score. Now you'll see that overall I've set the score to a tight 88. Now I can go tighter for the reason that we've sent the data through address standardization. So we've corrected, completed, parsed the addresses in a consistent format between the two sources. So I have a lot of confidence that I can dial this score up so that we don't introduce overmatching into the process. Now, we can also break that score down by the individual components of the address, such as the street number, the street name, street type, and so forth. If you don't set these individual scores or the scores at the individual components, we will simply inherit the overall address score. Now, because we may have a lot of multifamily dwelling units, high-rises, duplexes, townhomes, those types of things, I'm going to actually dial up the suite number fairly high so that we don't collapse multifamily dwelling units into the same address. Once we've done that, we have configured matching. We can do some options here. Maybe I want to output the match info and output additional score information, but to do that we need some information so that we can output appropriate flags and keys as part of this additional info, and that maps very nicely to these metadata tools that we dragged into the job to set those values. So you'll notice that these align very nicely. We have source, we come down here to our source name, we have priority, and we will have priority, and so forth. So suppress, there is a suppress flag, and finally internal, there is an internal flag. So at this point we've actually configured the matching, and let's see, we've got it here. Let's make sure I've got, must have the wrong flag in here, so let's take a look here. Oh, that would be right. I did not point to suppress, it's pointing to the internal. So at this point we have the matching configured. Once we come out of the matching, what we will have is every record will have an ID, and if there is any overlap between records, they will share the same ID. So what I want to do at this point is actually split my records out between my sales and my accounts. So using that metadata that we assign to each of the data sources, I can use the source field or source name field and set it to equal to sales. So those coming out the Y branch will be our sales. Those coming out the no branch will be our accounts. At this point, I can then join the data between the two sources, and I can leverage the key that we built off of this. So I'm going to use the person level key that we assigned as part of the matching. And ultimately what we have as a result of that coming out of the join are those records that overlap between the two sources. So let's then take those results. I can send those results to a couple places. First of all, I can actually take that data and send it outside of the cluster if necessary. So in this case I'm going to send the data outside of the cluster, and this data can then be run down to other systems, other databases, or files that downstream systems can then leverage for additional processing. I'm also going to persist this data on the cluster. In this case, we've prepared a Hive database or a Hive table that allows us to stream this data directly into Hive. So let me get the table up that we've built. And so we've got a table pre-built for this, and once the columns pop up, I can quickly map the results of the data set or the results of the match straight into Hive. So very quickly, in a few minutes, we've built a process to take those two data sources and figure out what the overlap is. So at this point, let me run it and show you a couple of interesting things about how we process on Hadoop and what happens. So you will notice that as we're reading this data in from our ERP system, so this is data that sits outside of the cluster, we read that data in, we perform our address standardization, and ultimately we are taking the results of that standardization and the read from the ERP system and sending directly into Hadoop. So now we are streaming the data into Hadoop, and at this point you'll see that we're about 2/3 of the way there. Once we get through the 176,000 guest transactions, the next thing that will happen is that we will then take that data, both the data from the ERP system and our accounts that are persisted on Hadoop, and we will partition them based on that zip code that we selected across the cluster. So you can see that the partitioning is running now, and pretty quickly, I think the total volume count is about 27 million records. We quickly spread it across our cluster. Now, in a few seconds, we will begin to run the transforms. Now, the transforms were those tools that were inside this parallel section. We will begin to run those operations against each sliver of data or each partition of data on the node. So to show you that, I'm going to go to our management console. In a few seconds, you'll see all of these transform projects pop up. Now, you can see we have up to 25, 27, 28 different partitions running of data. So I'm going to connect to a couple of these just to show you what we can do from a visual standpoint. And let me connect to this guy as well. So what you can see is if I flip-flop between these two processes, you'll notice they are the same graphically. But at the end of the day, these are different tasks running, or the same task running on different partitions of the data. Now, we have a couple cool features around being able to graphically understand the progress, also to understand the resources being leveraged. If I zoom in here, we will be able to, one more little here, we will be able to actually see or understand what kind of resources are being leveraged on the node or the cluster itself. So for this individual tool, we can see CPU time, disk, memory, threads, and so forth. Now, the interesting reason why I showed you both Transform 1 and Transform Project 9 is because they are actually both running on the same, they were running on the same cluster. So if you see Transform 1, it's running on node 7. If you see Transform 9, it's also running on node 7. So what that goes back to is the native parallelization that we have built into our application actually allows us to run multiple tasks on multiple partitions of data on the same node. So you get additional levels of parallelism that you wouldn't natively find with other tools in the Hadoop ecosystem. So having said that, I'm going to turn it back over to Jamie for the rest of the presentation.
Great. Thank you very much, Chris. And you know, a few key factors to consider as you're on your journey to the modern data architecture. Oops, hang on. Are that traditional data architectures are indeed under pressure by these new data sources in their scale. You should be insisting on data management that integrates and leverages your modern data architecture at scale in a cost-effective way. And your development, your implementation, and your production costs and schedules can be significantly optimized if you can leverage your existing DBAs to load the data in, clean it, integrate it, persist it, and key it in the Hadoop environment. And archiving data off of your enterprise data warehouse and eliminating the costly ETLs that schema on write can be avoided if you build out your Hadoop cluster using a data management application that can span both environments and eliminate the complexity of Hadoop as well as the need to code. Your data lake journey becomes a lot smoother when you demonstrate consistent cost reduction and build raw data granularity that's necessary to support advanced analytics. Next one is getting your business application into production is easier when your data management application can load, clean, integrate, and prepare data for any application existing on New. And making data available for any application across a hybrid or a data lake environment is a critical consideration to make when you're choosing how to do your data management. Using a single application that your existing DBAs can master within a week can shorten the journey considerably. And this is done by eliminating a lot of the new application development that might require new coding complexities, achieving and surpassing your performance benchmarks for both development time and processing speed, as well as automating the execution of a broad set of data management jobs that can scale across all of your database environments. And lastly, you want to use a design model that's consistent with your modern data architecture. So, you know, the fact is data quality and data integration are computationally intensive, but if you take your application to the data, you can really leverage the power of Hadoop. So I'd like to thank everybody for joining us today and to open up and answer